Hey everyone, welcome back. Today we are diving into the world of artificial intelligence and machine learning to explore something super cool: convolutional neural networks, or CNN. Don't worry if you have never heard of them before. By the end of this video, you will understand what they are, how they work, and why they are so important. Let's get started. First, let's start with the basic. What exactly is a convolutional neural network? A convolutional neural network, or CNN, is a type of deep learning model that's really good at analyzing visual data like images and videos. Think of it as a super smart system that can recognize pattern just like how our brain process what we see. For example, it can look at a picture of a cat and say, "Yep, that's a cat," right? So why do we use CNN? Well, here are three big reasons. They automatically detect important features in images like edges, shapes, and texture. They are way more efficient than traditional neural network because they reduce number of parameters. They are amazing at tasks like image classification, object detection, and even facial recognition. Basically, if it involves visual, CNN are the go-to tool. So let's start with key component of a CNN network. So first, there are convolutional layer. So the convolutional layer detect features like edge, pattern, and so on. Then after the convolution layer, there is a pooling layer. This pooling layer reduces the size of the data, and we have a multiple layer of convolutional pooling, and so on. And then we have a flattened layer, and finally we have a fully connected layer that combines feature for final prediction. I will break down each layer. Let's start with convolution layer. So convolution layer applies filters, or sometimes they also called kernel, to a input image to detect feature. Let's concentrate with this single channel image, where this orange color rectangle box is the image we have. Then you see a gray color 3x3 box. So what convolutional layer does, it implies this filter on this gray region. What operation it does is just multiplied each value. So it is a 9 multiplied by 0, you got 0. Then 5 multiplied by 1, you got 5. Something like that. Then, so it is a element wise multiplication. After that, it adds up the whole thing, and it gets 7, which is, you see here it got the value. So it puts 7 in the result matrix. So what happened, there are two more terminology we need to understand. One is called stripe, and another one is called padding. So stripe is how this filter slide in this image. So if there is one stripe, then it will slide only 1 pixel. So if this is the region, the next would be 1 pixel slide. So that would be the new region of interest, and the filter implies on that regions, and so on. And the padding is that, so if you want to get the result of this first pixel, or this first pixel, you need to add some value outside of this image. So here it comes padding. So this is 0 padding, so it adds 0 all over the image, outside of the image, to get a region like this, and then it extract the value using the same filter 19. In convolutional neural network, we use multiple filters with different values to extract different kind of feature out of it. Next, talked about pooling layers. So pooling in convolutional neural networks is a technique for generalizing feature extracted by convolutional filter and helping the network recognize the feature independently of the location in the image. There are basically two type of pooling layer. One is called max pooling. So what it does, if you see, there are stride of 2, so that means 2 by 2 matrix will be considered, and it will get the maximum value. So for example, here in this green box, the maximum value is 12, so it replace, so it only take 12 out of it, and so on. So in this next 2 by 2 box, it will take 7, and so on. So this is the max pooling. And there is another type of pooling which is called average pooling, which will take the average value of the box. For example, this green box, if you take the average, like sum all of these values and divided by 4, then you will get 9. So there are two type of pooling we can use inside the CNN. Next, there are flatten layer. So flattening is used to convert all the resultant two-dimensional array from pooling feature map into a single long continuous linear vector. The flattened matrix is fed as input to the fully connected layer to classify the images. Now let's talk about fully connected layer, so which you will find at the end of a CNN. So the fully connected layer combines all the feature learned by the previous layer to make final prediction. So this fully connected layer will give an output that might tell us, so if we are classifying an image for cats or dog, then it can tell us whether that image contain a cat or dog. In fully connected layer, even in previous layer as well, sometimes we use dropout. So this is due, we call it regularization. So basically a fully connected layer occupies most of the parameter, and it is prone to overfitting. One method is reduce overfitting is dropout, which is introduced in 2014. At each training stage, individual nodes are either dropped out of the network, that means they are ignored, with a probability. So we set up a probability. So how many node will be drop out? So here in this example, if I set a probability of 0.5, that means from input layer to dropout layer, as you can see, there are 4, and it will drop out 2 because we set a probability of 0.5. It only keeps the 2 node and then move forward to the next layer for this example, which is a classification layer. So this dropout layer, only the reduced network is trained on the data in that stage. The removed node are then inserted into the network with the original weight. So basically, so this dropout layer keep in the training stage, keep the training out of overfitting, so it reduces the overfitting. Then finally we need to talk about activation function. So an activation function decide whether a neuron should be activated or not. This means that it will decide whether the neuron's input to the network is important or not in the process of prediction. So one example is presented. This is a ReLU activation function. The main advantage of using ReLU function over the other activation function is that it does not activate all the neuron at the same time. So here you can see this part it has a 0 value, and this part it has a linear progression value. So some neurons will not activate and some will activate if we use this ReLU activation function. Then there are a sigmoid. So the sigmoid is basically used in binary classification in the CNN model, and we also have softmax. It is used in multinomial logistic regression and is often used as the last activation function of a neural network to normalize the output of a network to a probability distribution over a predicted class. So these are the three main activation function. So this is an example of sigmoid activation function. So let's wrap up everything. So in summary, we can say that CNN are powerful tool for analyzing visual data. They consist of convolutional layer, pooling layer, and fully connected layer. They are widely used in image recognition, object detection, and many more applications. Thank you for listening.